your lesson for Tuesday. Now, pen. All right. This time we're going to solve some complex number cubed equals -8. Just be aware it could be written like this. And we're trying to find the solutions here. We're in the world of complex numbers. This is not like on your test, on your functions test, you had this, and I got a bit frustrated that people expanded this because there was no I here. So if you just got, real coefficients, you've got, one solution. -2 cubed or -2 cubed equals -8. You're done. But we're moving on to complex world, and there are going to be 3 ways. So we've just found one of them, -2, but there's 2 other numbers, as in 2 other numbers that fit this complex number form, a plus bi, and when I cube them, the answer will be -8. All right, so we're learning to find these with de Moivre's theorem, and let's show you a way you could go about doing that. So complex number cubed, you could say that it was 8 times -1, right? And the -1 I can easily write as cis pi. Let's draw it, if you're wondering, on our Argand plane, which I need to sketch every now and then and refer to, and you should be too, because pictures make your questions easier. So there's -1. The angle is pi to get there. So keeping it at 1 keeps it easy. It's got a modulus of 1, length of. So instead of writing 8 times -1, write this. Where's the pen here? Cis pi. Now we're going to find 3 roots, so I'm going to need rotations around the circle, if you will, or around the Argand plane. I need multiples of 2 pi. We're doing that with k, right? Our k is an integer, and our k, to find 3 roots, the easiest way would be use a 0, a 1, and a 2. All right, now you need to cube root, so z will be cube root of 8 is 2, cis, what do we got? Pi plus 2k pi all to the power of 1/3. So, all right, I've done the power of 1/3 on the 8 already, and I'm leaving that out of my consideration. But I've got cis pi plus 2k pi to the power of 1/3. We're now going to use de Moivre's theorem. Cis, so we've got pi on 3 plus 2k pi on 3. Right. Because de Moivre's theorem says you need n theta in here. And I wrote that in the last video. I won't write it again. But what I do need to write is that I've just used de Moivre's theorem. So make sure you're doing that in your working out. Okay, so what happens? We will get 2 cis pi on 3, which is interesting. We'll get 2 cis. All right, so now this is the first one. I made the k0. You can see I've written k0, 1, 1, 2. So that was all 0 to get the pi on 3. Next we're going to need k equals to 1. So we'll have 1 pi here. We've got 2 pi's there if this k is 1. So we've got 3 pi on 3. That's just pi. All right. Hopefully you're with me here and you realize that this was the solution minus 2. Cis pi, it's here. I've drawn it already. Times 2 minus 2. And that's one of the roots. The last one will be 2 cis. Now our k will be 2, so we'll have 2 times 2, 4, plus another 1, that's 5. So we get 5 pi on 3. I do want to draw them, and I want to write them in Cartesian form, so should we probably do it up here. Just so I can get rid of this stuff. Oh, yeah. I might actually just forget the 2's for a minute, so that we're kind of thinking about unit circle again, even though we're on our plane. So we're at pi on 3 is about here. If we were on a unit circle, this position would have cos half, and the sine would be root 3 on 2. Right, we're on the Argand plane, so I'll put the little I in. We could then come over here. And that one's pretty straightforward. The cos is minus 1. The sine is 0. And the last one was at 5 thirds. So where's that? That would be about here. And that's supposed to be 1/3. I maybe should have rotated a bit more. All right, halfway is 3/3. Then you've got a third there, 4. So you're kind of about here, 5/3. Ugh. And unit circle numbers, cos is half, sine is negative root 3 on 2i. Something interesting here is that these two are conjugates, so you're picking that up. Right, we do have z and its conjugate as 2 of our roots. Something else to notice, which I discussed in the last video, is that we have 3, so as you'd expect, but we have on our Argand plane 3 evenly spaced solutions, right? Or evenly spaced complex number. All right, they're all rotating, if you will, as you go around by multiples of 2 pi on 3. You can see it in the equation I've got over here. Okay, so to convert this to a Cartesian form would be pretty straightforward, because I know what the positions would be on a unit circle, right? So, 2 cis pi on 3 is my first one, would be 2 cos pi on 3 plus I sine pi on 3, which I've already written down. This is probably a bit overkill, all this working out I'm doing, but that's all right. So you got 2 times a half plus I root 3 on 2. And that means you've got 1, if you do it 2 times a half is 1. 2 times root 3 on 2 is just root 3 I. So what we could be writing for the first one, I'll do the next two quicker. Just want to show the full explanation. Oh, is that a bit? Yeah, little. All right. So this first one came out to be 1 plus I root 3. And what I'm saying to you at the start of the video is that if you took that value and you cubed it, you should get -8. All right, so you can go try that in your calculator. That looks like it's a 2, but that should be cubed there. Just like here, this one you already know, -2 cubed will give you -8. And over here, we have to times these by 2. So if we've got 2 cis 5 pi and 3, we'd have what? 1 minus I root 3. So there's our 3 roots in a Cartesian form. I think I've covered everything. We could quickly go to a calculator if I can get one to work. Where's my calculator? I'll try the last one. 1 minus I root 3. Did it? Is this going to work? Is this going to work? Maybe not. If not, you can do it on your calculator. Cube that solution and you will get -8, -8. No, it doesn't seem to be happy. So I might... Oh no, it is working. All right, get rid of all that. Haven't used this for a while. Since we did vectors, it would seem. Okay, so we got, what did I say? 1 minus root 3. Oh, I should probably check. I think I might need to be in complex mode. Maybe not. I's down the bottom there. Square root 3. We're going to cube it, and we're going to get -8. Plus 0i. Okay. Maybe I don't need to be in. Anyway, I think for this section, just set your calculator to this a plus bi. Did the same thing. All right. Anyway, I can't think of anything else to explain. So I think that's it. Remember to write de Moivre's theorem. Now that should be enough to get you started. I might make another video. I'll have a think about it. Hopefully you've enjoyed this one.